Namaskar and good afternoon, ladies and gentlemen. Once again, a very warm welcome, requesting everyone to be seated with all mobile phones kept on to silent mode from now onwards, please. And ladies and gentlemen, we sincerely hope you all enjoyed the sumptuous lunch served to us by the Manekshaw Center and our gracious host, SIA-INDIA. We are now all set to move ahead with the proceedings of the next panel discussion, which is on command networks and satellite operation centers, the CSISR backbone. And I have the proud privilege in inviting on stage our distinguished chair, Lieutenant General PJS Pannu, PVSM, AVSM, VSM retired, former Deputy Chief of Integrated Defense Services. Let's put our hands together to welcome sir. Also inviting all our eminent panelists, Colonel N.S. Dabhi, DSA, DG Signals, Indian Army, warm welcome. Inviting Mr. Noel Ballot, Executive Vice President, Sales and Marketing, Safran. Inviting Colonel Alok Parashar, CEO, Geminus Space. Inviting Dr. Krishna Chandra, Chief Mentor, C2C Advanced Systems, and Mr. Sireesh, Pallikonda, co-founder and CEO, Ballon Aerospace. Ladies and gentlemen, a very warm welcome to the session, Command Networks and Satellite Operation Centers, the CSISR backbone, which focuses on invisible architecture that powers real-time situational awareness, secure data exchange, and joint force decision-making. Before I request Lieutenant General PJS Pannu, our distinguished chair, to kindly take over and lead this important conversation, I would request, sir, if you could kindly close by 10 minutes past 3, as we have some MOUs to be exchanged in this session after the discussions. Over to you, sir.
Jai Hind, good afternoon. Post-lunch is the best time to moderate a discussion of a panel, for the reason that you only get serious players. They're not hungry for food, they are hungry for knowledge. So they are here. So what is important here when we talk about space, which is very important as far as national security is concerned, we all spoke about it since yesterday. But if you have the space assets available to you, but you do not know how to realize the services of the space, how to make sure that every element of space is optimally used by those who are actually stakeholders, and whatever you are investing, it is worth the money spent. So when we are talking about command networks and satellite operation centers, obviously we are talking about that there are satellites in business, yet we need to have elements for command and control. You have to command and control the assets which are there in the orbits. You also need to have ground stations which will download all the data which has been gathered through the satellites for which they were configured. We take a great care in configuring the satellites so that our satellites are either giving us the data which is processed at edge, or the data that comes down gets processed in our command and control centers. So very different kind of technologies are coming up. The technologies become legacy because sometimes this satellite is of vintage, 10, 15, 20 years maybe. But now the asset is already up. What do you do with that when you want to upgrade the technology, which becomes quite a bit of a challenge, yet it is still an asset of yours which got to be put to good use. So we are going to be really talking about how are we going to achieve real-time situational awareness. And here I'm not talking about space situational awareness alone. I'm talking about situational awareness, which is persistent ISR, which is persistent services, and how do we use all that is available to you for good decision making. We will also discuss the architecture, how it is to be modernized, what kind of architecture do we have, what architecture do we need, and how is the future secure connectivity got to be achieved. And from the analog systems, we have gone digital, digital to autonomous. How do we strengthen India's joint command and control responsibilities? So I use the command and control very differently from giving a gap between command and control. Normally we talk about C2 as one breath. So we will, from the panelists, understand how are they looking at the command and control of the systems. So they have got to also talk about the medium, which is communication. They've got to talk about spectrum. We've got to talk about networks. We've got to talk about the analysis, interpretation of it. And at the end of it, data security. What is data? How, on one side, what do you mean by collecting data, raw data? And what do you think of the usable data? Now, all data which is coming to you is data which you have either asked for, or a lot of data will just come in. So what do you do with the entire data? Would you just load it in your systems and crash your systems, or would you make sure that you have a layered system in which you get what you want, process it, and speed is of utmost importance. And we always keep talking about OODA cycle. OODA cycle has to be secure and it has to be shared, so that you take a decision which is yours, because your artifacts are yours, they got to perform for you. So I will now go from my left to my right, and ask each panelist to speak about what they have in the opening remarks for about 3 minutes, and then we will have a discussion. So may I, Sireesh, we'll start from you, and then we'll go from my left to my right.
Good afternoon, everyone. So at Red Ballon, we are developing the high altitude platform systems, basically. So this is indeed one of the very youngest company which is presented here. So it's been like just 4 months that we started this company, but we made a significant progress in that direction. We are developing these apps, as I mentioned. So what we are trying to do at Red Ballon Aerospace is bridge the gap between the satellites as well as the aerospace. So there is one common word that we quite often hear when we attend DefSat, that is the torchlight and integrated to the spotlight. So there is in between some layer which is missing, that is called the near space, and it is quite difficult to operate between 20 to 50 kilometers of altitude. And we are developing these airships as well as the high altitude balloons and the aerostats, which would be operating in that particular altitude and can carry much heavier payloads in contrast to the satellites. So the payload is not a limitation. And apart from that, it would be persistent there and can be looking at the same location for very long time. So endurance is not a problem. So this is something like to the geostationary satellite, which is 1800 times at a distance to the HAPS what we are operating at. So we can give a better resolution, and this is the solution what we are bringing to the markets. Yeah. Thank you.
Thank you very much, Colonel Alok.
Good afternoon, everyone. I'm Colonel Alok Parashar, Chief Product Officer of Geminus Space. We are based out of... Audible now? Yeah, so just repeat. I'm Chief Product Officer of Geminus Space. We are based out of Pune, and we are building solutions for ground operations for the space infrastructure. So the space infrastructure, when we say, it includes command and control centers, the stations used for TT&C commanding. Also, once you receive the data, the processing and last mile delivery. When we talk of last mile delivery, the last soldier, how he is fed with the data. This is where we are working, and we started with solving 4 definitive challenges here in the space infrastructure. First one already well brought out by General Pannu. He is like data saturation and cognitive overload. That is, lot of data is produced by these satellites, and at some point of time there is data saturation, also a cognitive overload on the people who are going to consume this data. So how do we refine this and right information or insight reaches the right people, right? That's one area. Second is interoperability is one big issue. Why? Because a lot of systems have come from different places, utilized by different departments, and they have their own architecture, own protocols. So in many cases, there is no intercommunication right now. So this is one area which we are solving by software-defined standards that some of them are already existing and some are customized specifically for the ISR operations. Right. Then another part is latency and the tactical edge. As of now, space is more seen as the strategic asset, wherein planners at top level are able to utilize this data well. However, the latency is so much that the end user, the last soldiers, when the insight is available to him, the target is already gone. Right? So how do we reduce or accelerate the OODA cycle, wherein the first two O's, which are observe and orient, that we are able to reduce as far as possible. So these are the areas that we are working on, and we'll talk about what kind of platforms are needed right now to really address these issues. Thank you.
Alok, I think maybe my war game scenarios have been leaked out. You've spoken a lot about what we are going to be discussing tomorrow. Over to Colonel Dabhi. He's from the DSA, DG Signals. So your initial comments, please.
Good afternoon, sir, and thank you, Chair, for giving this opportunity, and good afternoon to all stakeholders, I would use the word. Myself, Colonel Neerav Singh Dabhi, and my desk looks after the SATCOM for Indian Army, as part of which we basically do operation and maintenance of the operational networks. We plan capability development, and most importantly, we also handle the regulatory aspects. So my today's contribution, or my today's basically aim, would be to slightly address these regulatory aspects from the perspective of SATCOM, as and when we go ahead in the panel, and to highlight, firstly to highlight what are the challenges, and also to attempt giving what are the possible solutions. So that is where we stand, and we also are the single point of contact for ISRO for any kind of spectrum management issue, and so is for DOT. So with that as a short introduction, I'll be bringing out the certain regulatory aspects as and when we go ahead as part of the discussion. Thank you, sir.
Thank you. Thank you, Colonel Dabhi. Noel, you are a voter, which is very powerful. He has the power of ballot. So I think we have to give him a little more time.
We say ballot box also in the US, but so there's no problem with the spelling. So thank you for the introduction, General Pannu, and thanks to SIA for the invitation. It's always a pleasure for me to come to this kind of meeting. I don't know if all of you were here in the presentation this morning, but definitely we highlighted our capability of providing ground station, not only we as Safran, but also providing Indian ground segment with the collaboration of Safran Data Systems in India, but also a company from new space like Avantel or Jura. So it's my task is also to develop the technology transfer of production and transfer of maintenance to Indian partners. We have big challenges regarding the ground segment these days because we are in a transition from geo SATCOM type of things to LEO SATCOM. LEO was used previously only or mainly for Earth observation. Use of LEO with use of LEO satellite for telecommunication has been, let's say, standardized, or I should not say standardized, but really promoted by Starlink, SpaceX. OneWeb, I know there's quite extensive use of OneWeb here. There's a need for more bandwidth, so going from C-band in the past to KU band to KA band, and maybe tomorrow QV. So there are some technical challenges. I see also more and more optical communication, optical ground station. We use also the optical interlink for satellites, which is very powerful and works well. When we are speaking about optical ground stations, there are challenges of the disturbance in the atmosphere, which is a problem. Regarding ground segment, also, when we are speaking, a regular requirement, we can have fixed ground station, but more and more we need tactical ground station for having quasi real-time, it's not completely real-time, but image processing done close to the operations. And this is also a focus of development. Again, we have to protect the assets, so we have to protect the link between the ground segment and the satellites. So cybersecurity is also a big challenge these days. We have heard so many cyber attacks lately, so I think I will stop here for my overall presentation and open to questions.
Thank you, Noel. Again, tomorrow's war game. I think
Yes.
if you're around, we will benefit from your wisdom.
With pleasure.
on how to do things and how
Tomorrow
probably
afternoon.
that you should not do things, which is lessons learned. I go on to the last speaker for introduction, Dr. Krishna Chandra. We are talking about command and control, and your name is Command and Control Advanced Systems. So it means whatever others do, you do it better, advanced. So let me hear your comments for first 3 to 4 minutes.
Good afternoon. I'm Krishna. I mentor an organization called C2C Advanced Systems, which has some of the best minds in the area of command and control. As you rightly said, sir, control is dependent on the sensors and the ability for you to capture all the sensor data in whatever form it is and make sense out of it. Otherwise, there's no command. So that's kind of the space that we've been building. We have our own proprietary platform which integrates sensors, seekers, communication data into a single platform. It's been applied in a number of frigates globally, and we have been working with the military in India to propagate the concept. It's a very current generation, using current generation sensors. The challenge that we have is that if you have to build this in the existing architecture that the Army, Navy, Air Force has, it's always very difficult. Nobody wants to discard anything. So, but in the space, there is an incredible opportunity to build this both ground up and top down, the command and control architecture in space. I personally believe that if you don't build satellite sensors, the ground control, secure communications, data services, leading to autonomy and resilience that is indigenous, I think sustained national security cannot be obtained. There is no chance of it. And that is kind of the critical area that we need to focus on. We also think that robust command networks are essential in space because this is actually going to be the backbone of any warfare that takes place. And the current warfare is not, it's a multiple domain warfare. So all multiple domains that you have require space as your backbone. And if this backbone is not resilient and autonomous, I don't think we have the ability to command and control the entire warfare. So that's kind of the basis on which we are building. We have about 250 people just focused on integrating sensors, seekers, communication, and data. Thank you.
Thank you, Mr. Chandra. Out of the speakers here, we have two speakers. Sireesh spoke about HAPS from Red Balloon. He's spoken about the payloads. He's spoken about the resolution. He's also not spoken, but I would attribute it to sovereignty, that you are more within the area rather than global. So you can be actually sent up for whatever time it is required. You will consume less power, but you will deliver better. So I wanted to ask you, if you're going to go into HAPS, which is the near space, would your technology or near space one day would discard the entire story of space constellations that we are building over time?
Yeah, that's an interesting question indeed. We are not competing with any satellites or the for the airspace segments such as UAVs or something like that, because they've been doing wonderful job what they are doing. So satellites are for the global coverage. It's not just the the sovereign ISR that we need to have. We need to have the global ISR as well. So satellites would be best in what they're doing. However, there are certain gaps, okay, that need to be filled, and that also cannot be covered by the UAVs. So how we see this as a global coverage through the satellites, and near space coverage, like that will be giving you the local visibility, whereas the UAVs could be more tactical. That is the first point. And on the command and control, like when we are speaking about this, like we see that huge amount of data would be generated, because it is not just one system. It is the integration of naval, air force, army, and many other things, including the cyber what we are speaking about, and the AI. So when we are speaking of such a huge quantity of data, okay, would the satellites alone be able to support this through NTN or something else, or would be the only MNOs? So beyond this, we need other support. That is where this HAPS would be coming into the picture. And again, in this HAP, we want something to be more persistent and be there for very long duration and provide this solutions to the requirement. Yeah. I hope that addresses your question.
Yeah, see, have you got any experience, which I'll talk to you later,
Yeah,
but
sure.
you just keep it in mind, that the audience would want to know from you when you talk about HAPS. Traditionally now space is more known, the LEO, MEO, GEO, all that story is known, ISR is known. We need to understand some success stories and some challenges and some experiences from HAPS. Then perhaps we can really look at more HAPS. But I'll come to Colonel Alok. There are two players here who spoke about the ground segment. One, of course, is your Gemini, and then we have Safran. Both of you are into making ground stations. So I'm sure even the same ground stations would be used by HAPS, right? They will be used by LEO, MEO, GEO, all configuration.
Yeah.
Are you prepared to say that anything which is there in the space or near space, you will be able to aggregate all the data, whether it is LEO, MEO, GEO, or it is comms, PNT, and ISR all put together? So how does your configuration work so that I can have a triad of the 3 orbits and the triad of different types of services like PNT and ISR put together with communication? Will you be able to aggregate all this? And can satellites then be put together to stitch it there in the orbit itself and give you processed information? So do you think you will be able to configure something like this in the ground configuration?
Okay. If I have understood your statement correctly, sir, there are two aspects to it. One is doing all the aggregation on the ground through the ground stations, and there is a different aspect altogether if we are talking about inter-satellite link, as to be able to consume the data up in the orbit itself and be able to process and get it here right away. So as far as the later part is concerned, inter-satellite link and processing on board, we have some distance to cover if we have to achieve that. But what is really possible right now is aggregating things on ground. And of course, the ground stations for comm satellite and Earth observation are little different to each other. But at the top level, if we talk about the infrastructure, what we have started to do is building those adapters so that different kind of sensors are able to send their data and be consumed by our infrastructure, which is underlying. Second aspect, what we also tried to do is making it future-proof in a way that this ground infrastructure has been made in a modular fashion and scalable manner. We know that if we are going to have a lot of satellites tomorrow, there is not a single day that these all satellites will arrive. They will get launched over the period of time, say 3 months, 6 months, 1 year, and over the period of time we'll have so many assets. Of course, we need the scalable architecture. We also need a modular architecture. Why? Because with each new mission, new types of sensors will come in, and then new types of adapters will have to be built to be able to consume that data. That's one part. New types of functions and features will also have to be incorporated, because while we are working towards infrastructure, the application part is also seeing a lot of improvement, say detection capabilities, classification capabilities, identification of target capabilities. Newer applications would start cropping in, starting from very basic, like even cloud detection and other things, even to the extent whether this imagery is usable or not usable. So we need to keep up with that. So our structure has to be modular in fashion, so that new algorithms built by our other partners in the industry, we are able to take that on our platform. So we have to make it future-proof also once we are building such a system. So that's what we are doing, and at very broad level, it is adapters and those right infrastructure which are scalable and modular.
Okay, thank you, Alok. I mean, I could have asked you the next question, but I will ask that question, the next question, to Noel, because you are also in the similar, ground stations and all. Suppose I bought a ground station from you.
Yeah.
And I tell Noel that, you give me a ground station, and you would ask me certain configurations of the ground station. So you have to tell me what satellites, what do you want to do. So certain questions you will ask, which I would want you to ask me now. Second thing is that after we have settled commissioning your ground station, now a new company comes to me that, hey, take my satellite service. A PNT service now is there. Hey, listen, I can also, do you have a station? So please take it from me. New configuration of satellite communication happens. You go to, say, quantum, right, or optical. So tell me, in these two questions of mine, one is that what are the questions that you want? What are the qualifications you would want from me to enable you to configure Earth station for me? And secondly, once you have configured the Earth station, if I have to now bring new services into it, what do you think you should be either capable of doing it, or you will have to really go back to full left and rebuild it?
So it's a very important question, I would say, because there are two aspects. Either you want to address one satellite or you want to address any satellites. This is the first, so what we call multi-mission. Our designs is by nature multi-satellites and suitable for ground segment as a service. most of the players of ground segment as a service, whatever they are, Kongsberg Satellite Services, Swedish Space Corporation, Comtech, and many others, they are using our antennas, which are designed to address any satellite, thanks to the scalability and the modularity of our architecture. It's based on software-defined radio, so when it's RF, it's tri-band, software-defined radio, easy to handle, everything is on the network, crystal clear. When it gets to optical, it's different sensors, it's different, I'm speaking about optical communication, okay? We need to have a different type of ground station. Right now, it's in the early phase of deployment of optical ground stations. So we have two kinds of ground station. One addressing receive only, and one addressing uplink and downlink. The configuration uplink and downlink today is limited in terms of bandwidth, but we can do 60 gigabit per second, and we have requirement to go to terabits a second. It's within a time frame of about 2 years.
Okay, so I understand that there is some amount of flexibility which is already configured in the system that you would give.
Yeah.
But you're not ready for everything that would happen, because if there is future in the satellite, there is also future in the ground station. However, I think a lot of data will have to be taken from a service provider who wants to rig up a ground station, what kind of a service he wants, what type of satellite he has, what are the frequencies he's operating on, what are the bandwidth that he's requiring. If there is any latency, then I would say, hey, listen, she said, no, it's not my problem, it is the problem of the distance and these satellites. Throughputs are different of a satellite. So I understand where you're coming from. So I come to Colonel Dabhi. Military communications have to be reliable, have to be persistent. There is huge amount of movement which happens, which is not predictable. There is huge amount of artifacts, movement which is happening for autonomous systems. Do you have enough bandwidth? Do you accept a latency up to a point and not? You would have put 5G under trial. You would be looking at 6G. You're looking at bandwidths. You are looking at maybe terabytes per second coming in for autonomous systems. How are you looking at a spectrum management and the regulatory mechanism that you had mentioned about the DOT, that you need your spectrum, you need your technology, and you need the regulatory systems in place. So can you talk about it?
So, sir, firstly, I would like to submit that the question is very apt, and I would like to start my answer with connecting few dots which has already emerged as part of the discussion. So, firstly, there are few words like command and control we have discussed, somewhere battlefield we have discussed, and somewhere the tracking and autonomous systems we have discussed. Now, if I add on that, whenever all these factors, whether it is the command and control, and in terms of I would say military perspective, whenever we see the satellite communication emerges as one of the distance agnostic, and I would say sometimes it is the only and the only reliable media which is available when the everything else is in that, I would say, fog of war. With that as a background, I would also like to refer to what Colonel Alok just now said, that broadly we all are aware that there are 5 verticals under which the space and satellite function, whether it like PNT, ISR communication and SSA and even I would say ASAT. But sir, if you look at the core of all these 5 verticals, it's a SATCOM which is acting as a core. So if we agree that yes, whenever it is a military SATCOM, there is a satellite communication is one of the backbone, and if we see that communication is the backbone, that is where Now I come that all of us, we must have come across that recent years, we have seen a huge paradigm shift in terms of 4G, 5G, 6G. It has been an exponential growth. We all have witnessed. So I take this forum to basically give out a very unique and I would say different perspective of, this 5G, 6G or IMT progress, how it is impacting or how it is reflecting onto the defense SATCOM, sir. So if I just take all of our memory lane back to say somewhere in the mid 2024, that was the first instance that year has seen the most of the policy reforms, and we have come across the words like reforming. What does it mean? We have seen there is the extended C band. It has gone as part of reforming. By the time we were able to adjust C band, again it was actively being reconsidered for reforming. So this happened in 2024. It gained some traction by, I would say, mid 25, and then it settled. This is where I would like to pitch in that it is not settled for, I would say, the military or the defense stakeholders. Reason? Sir, we are all these defense, I would say, stakeholders, defense SATCOM stakeholders. We all are aware that all this reforming has primarily happened into a very crucial and critical sector which is known as mid-band. Now this is where the military SATCOMs are classically built upon. This extended C, C, X, they are known, these bands are known for three things. Firstly, they are robust. They are able to withstand any kind of adverse weather. They are able to withstand any kind of countermeasures. And despite of all adverse weather and countermeasure conditions, it is giving you a data rate which is, I would say, decent, stable, and it is able to support command and control. Now, with extended C gone, we had a hope that, okay, we have got the entire C band left. What happened in, again, second quarter 2025, there is a portion of C band that also being considered. So somehow the stakeholders actually, we acted as a kind of, proactive steps. We were able to stem this C band up to 2030. But this is the point where I would like to raise a question, okay, sir, what beyond 2030? So somewhere in the academia, there was an answer that, okay, you have still got mid-band available in form of, I would say, X-band. But sir, I would like to draw attention that last month there is again news clippings in the on the air that even X-band is also being considered for refarming. So my aim is that if these are the refarming scenario which we are looking, so on one end there is an exponential growth in 5G, 6G and IMT because of this refarming, and we as a defense SATCOM stakeholders, we have to look this refarming from a different perspective. So yes, there is a challenge, but do we have a way ahead? Probably yes. Why? Because presently, as I told you, that with extended C going, the remaining midband is still as part of, I would say, discussions or policy reforms are still happening. So my point on this would be, this is the right time that we as a defense SATCOM stakeholders, we became part of some sort of, consultations, some policy reforms, some steps in which we are able to retain this thing as a strategic resource which we already have. And that is where I would like to pitch in that if should there be a kind of concentrated effort to preserve this critical midband which is very robust for defense SATCOM, that should be a kind of balancing measures like on one hand side, yes, there is a 5G, 6G, IMT, I agree, sir, but in fog of war, it is only this robust midband and military SATCOM which is going to come in use, and we have seen enough examples of in past 2-3 years whenever we have gone into the operational side. So that would be my.
Thank you. I have a lot of questions for you, but then because paucity of time, I think the MC also announced that they imposed a cut on us. The tariff deal is also applicable. I go to Mr. Chandra. Mr. Chandra, if somebody has to give you the command and control of their entire organization, how do you become trustworthy? Not trustworthy from that you cannot be trusted, you're okay, but that you can provide enough capacity. You will be able to address very large area, the oceans, the terrains which are like mountains, plains, deserts, some 25,000 kilometers of frontage if I expand it into certain configuration. How will you convince that you will keep your command provided you can affect the control. And how you're going to use communication, computer, cyber, all these networks together to serve a complete MDO package. How do you make such a big promise?
No, we don't make any promises. All we say is I'm agnostic to any satellites. They're birds in the air. The only thing I care about it is the ISR device that goes into it. If I'm going to be focused on the military side, and I need to be able to put a ground station that is able to take all the data and communication. For me, communication for the civilian sector is a commodity, but on the military side needs to be secured. So we are focused on that area. And the third thing I'm focused on is the amount of data, if terabyte per second amount of data comes in, you cannot put that into your networks and expect that the networks won't get choked. So I think that any ground station today, in our opinion, must have several features to it. One of them has to be the ability to do data analytics and ability to communicate relevant information through the system in a very secure manner. So command and control in this area has to focus how you are architecting the entire solution and not necessarily keep looking at it and saying, which bird I'm going to be dealing with and which bird I'm not going to be, because sometimes you may not have the capacity within all the satellites that India might have sent out. So we definitely have to work with others. But making them secure, I think, is a major issue here.
So I will take just 1 minute to do a jugalbandi between Colonel Dabhi and you for the spectators to hear them. A lot of people ask you, what is the defense band? What is spectrum? Are your capacities today, which are under use, the only ones which you need, or are you looking at some surge capability? So therefore, you have to explain to C2C Advanced Systems, what are your asks from him and what do you provide to him? Assurance of the bandwidth, the spectrum, the bands that you have, give it to him so that he uses it and gives it back to you in a trustworthy form. So can you quickly talk to each other for 1 minute?
Yeah. So firstly, coming to the spectrum part. So like as we are aware that the SATCOM industry part, it is very, I would say, spectrum specific. Like which part of spectrum the industry is using, that is how the capability and the infrastructure is getting built upon. So while there are certain very stable systems like C, extended C, or KU band and K band, these are the spectrum portions which are having the largest inventory which is already built upon. But then there are some spectrum portions which are emerging as a technology. Like for example, X-band in our country, I would say it's emerging. So there is a requirement of some sort of assurance from the industry side also that yes, if the stakeholders are going to build upon the infrastructure or capability building into X-band, does the industry have a reciprocal support or not? So this is one way to look at the thing. And secondly, as just now Noel also mentioned that the QV and these are the higher bands. This is where we are already looking for. Again, I would put the same question that yes, while I as a strategic stakeholder, if I start thinking that yes, my capability building is in those verticals, then I would like a reciprocal answer that is industry kind of ready to give us that kind of infrastructure and that kind of technology or not. This would be my one take. And
this is your extended 1 minute.
And lastly, very short, I would like to address the encryption part also. That yes, the military communication anywhere in the world, it will require certainly encryption. But yes, we have got a ways and means in form of modular encryption and implementation of that. So that is my bit on the things.
Look, as a company, we are working on PQC as one of the. We are working on PQC as one of the encryption that we are working on right now. My thought is very simple. We want to understand what the user wants and to be able to put together a technology package. To be very honest with you, I'm very agnostic as to where I buy the equipment from. People talk about, I think I've been a little controversial on this matter, people talk about startups and hoping that the startups are going to make something that Safran has been which Safran might have spent $100 million in putting something together, and you think that in a startup of 5 crores of rupees, you expect that it'll come out. But technology would have changed by the time it becomes usable. So I think one of the things that we look at it is we are agnostic to where we buy from. We're looking to ensure that their technology is transferred to India if it's in large volumes. Thirdly, we want to go with the users as to what exactly is their requirement and their security requirements. And we would like to run the center, although in a private sector, as though it is owned by the government. Because at the end of the day, in the military segment, it has to serve the national interest. And so France makes the same. In France also it's the same thing. Private sector does it, but the French government has a hold on it. So as long as that trust is established, I don't think there's a problem. But ultimately, the way I look at it is, you need to apply the best technologies, and don't be sitting there worrying about whether you're going to wait for a startup to come up with something. Yes, you do, but over a period of 5 years.
So are you also saying that, Sireesh from the HAPS domain can come to you to say, Chandra, I have HAPS, please put me into your command and control advanced systems. Would you do it?
Absolutely, because this is the only way that Indian systems are, self-reliance is going to come is when people get together and work together and solve their problem. But don't be afraid of taking in foreign technology in order to make your systems better.
Okay, thank you. So, just respecting the clock, Samay, I will ask anybody in the house if you have any questions. Please give out your name, short question, and if you indicate that you want to speak to a particular panelist, so please take his name. Please carry on. Yeah. I know you're noting down some points. You speak very loudly in any case.
Thank you, Pannu. So my question is for Sireesh. Could you just tell out the capabilities of your apps? What is this? What is the thing propulsion based on? How it's going to? What's the endurance levels? What the band are you looking at? Are you looking at LEO, VLEO, and endurance and capabilities in terms of other things? If you could be more specific.
Yeah.
And the TRL levels reached.
So when I say HAPS, like we are operating, something between 20 to 50 kilometers of altitude, and we have 3 different set of products, which is the balloons, as well as the tethered aerostats, and also the airships. So the balloons, what we have right now is the super pressure balloons, unlike zero pressure balloons. So one of the major difference is with super pressure balloons, you can have a larger endurance. You can be in near space for several months. But one of the disadvantage with these super pressure balloons are they are not completely steerable. So you don't have absolute control on them. So that's the reason like we moved to the airships. With airship, we'll be having the full control over them, and we can be persistent over one particular location for very long time. When I say long time, as of now, like we are looking at something 6 months. Every 6 months, we can bring it down and replace it with another airship, refurbish, and bring it back again. And coming to the payload capacity, right now we are looking at 300 kgs. And this is under development right now. And we are looking for the first super pressure balloon to be launched something next month. So TRL level with respect, like, all these 3 products, what I mentioned are quite modular in nature. So the balloon would be going into the aerostat, and from aerostat, it would be maturing into an airship. So on the TRL level, like we are at TRL 6 right now. With the demonstration, we would be reaching TRL 8 for the balloon, and eventually we will be going to the next 2 products.
Last question. Yes, please go ahead.
Yeah. I'm S. John, Managing Director, Comsat Systems Private Limited. The company is in Hyderabad, and for the last 35 years, we have been manufacturing. Initially, it is all with the geostationary antennas.
Please ask a question. You are introducing your company.
Yeah. You are asking whether the antennas are there for the Q, V, and this S band, X band, and Ka band and all that. We are getting them ready, and we are already manufacturing the antennas as it is. That is XY antennas or tri-axis antennas. So this is a tri-band and feeds are under, this one probably in another 3-4 months will be ready with the, feeds. So I am very, very confident that at least the ground stations.
Okay, so good news is that you can carry on with your sales pitch.
Sir?
I said you can carry on with your sales pitch. I have got time extension.
Okay, good. So I think I have given this one. All the antennas are ready. The ground stations we can provide.
Who are you selling this to?
Sir, somebody has said that.
You want to buy?
Yes.
No, they are all actually selling. Okay.
Good, thank you.
Thank you. Excellent. No, so his ground terminals are going to be ready. I think you can have a B2B meeting separately. Thank you very much for your question. Yes, sir.
Hi. Good evening, sir. I'm Air Marshal Sachdeva. Nirav, the concern which you've given, I'm giving a suggestion to everybody who's here, who's manufacturing things for us. This refarming started in 2007. It's 20 years. That time the defense was speaking from the position of strength. Today we are speaking from position of not so much of strength because commercial has come up forward. That time we were looking at the 1800 band, 1700 to 2000 megahertz. We were owning 1700 to 2100 in the defense band. Today we are down to 120 or maybe 100 megahertz. Nothing has gone wrong with the defense despite 200 megahertz going. Nirav, you will have to think of shrinking your equipment on the band available, and you all will have to give us things in as less a spectrum as possible. Go to ITU, find out what is the best solution they have given. Please come with that to the military because a lot is going to commercial. We cannot sit on spectrums worth of lakhs and lakhs of crores and actually run a system which can be squeezed in. So you all will have to work the entire system out here on as minimum the spectrum being used. We had 14 telecom industries, you wasting a lot of spectrum in between. Today you have 3 minimum wastages happening. That's the kind of solution will you all have to work on. Why I'm saying 20 years ago, because 2010 onwards, I was looking after this game. And today we are in a deep trouble if you don't use your spectrum judicially.
Wait a minute, Rajiv.
Yes, sir.
Thank you for this. I think more and more artifacts are going to be users of spectrum. We've not had in the past so many of communicating devices, the terabytes worth per second that will go into million devices per square kilometer. Do you think the spectrum that you're talking about is now future available to you? That kind of a capacity, you may like to answer that.
Yeah. So, firstly, thank you, sir, for bringing out the great insight. So, my take on this would be that yes, if the sir's suggestion, if it is taken by the forum, then it is the win-win situation for both the, I would say, industry as well as the users. But somewhere the point is that, sir, all these regulatory aspects, they are implemented firstly region-wise, secondly country-wise, thirdly I would say spectrum-wise. My point is at one point of time, all of us, we as a defense SATCOM stakeholders, if we rise above country, if we rise above respective region, if we rise above respective, even I would say, think of something what is happening in WRC. Sir, WRC, the warfare is about spectrum, firstly. Everybody, in today's date, the most prized commodity is not rare metal, sir, it is spectrum. I would say there is the spectrum, the usage is increasing, and that is why the word shrinking somewhere, sir mentioned. So, in this warfare of, everybody wants to take a pie of spectrum. That is where my point is that the SATCOM, I won't say industry, I would say stakeholders. Now, stakeholders is on the either way, whether it's on the industry part or onto the user part. We have to defend what is bare minimum and which is going to be future available. Because, sir, I would say the most crucial part about defense ecosystem is that what you plan today, you will get after 5-7 years. And if I speak the counter, what you want after 10 years, you have to think of today. So for giving that liberty of thinking today, we have to have certain policy which is very well defined and which is, I won't use the word favor, but which is kind of, in a balanced equation of industry as well as the stakeholders. That is my take on this. Thank you, sir.
Also, I think when you're in satellite business, then you are not sovereign within yourself to decide everything. I think there is an ITU framework in which you have to look at who has pushed more at the highest level and got more, and we are left with little. So some kind of a understanding of advanced planning will have to be done. I think we need to look beyond our own nation to see that how in the contested environment of spectrum we're going to do a business. Any more questions? I think this is all settled. So I have a few questions there. Air defense is now one big business where many nations are selling equipment for protecting your skies. Similarly, you have hypersonics coming in. From supersonics to hypersonics, I think we're again back to where we started. We've been talking about A2AD, anti-excess area denial. Where do you think the industry can step in for counter hypersonics? How do you handle the plethora of missiles that are being invested to hit targets in depth? So do you think we are ready for management of communications to be able to connect with this fast moving projectiles who got to be smart? So let's talk about it. Since you're from the air defense, I thought, I'll ask you, flying HAPS, of course. Can HAPS be shooter sensor agents? Can satellites be shooter sensor agents?
Can I comment, please?
Yeah, you can comment. In the meanwhile, let Sireesh comment.
Yeah, indeed, in the HAPS, what we are developing, we are also planning to integrate something like create a facility where we can provide the training how to counter this hypersonics basically. So when we are operating at 20 kilometers or 25 kilometers of altitude, okay, and if any missile or anything that is been released with certain force, okay, by the time it would be reaching the ground, like it would be into supersonic speeds already. And if it is ignited even few seconds before, it can definitely reach to the hypersonic speeds. So first of all, this would establish as a platform how to counter this. So certain training can be provided in this direction. And the second thing is when we have these missiles coming at such a high speed, detecting them and countering them need to happen simultaneously. And if we are operating at higher pedestal, that would give a better advantage. So that is what we are trying to test in our next launches as well.
Let's also talk about the space domain awareness. When you talk about the SSA, you're looking at debris. But when you're looking at these, adversarial gadgets which are looking at you, either in a non-kinetic manner, which can get something else connected for a kinetic, damage onto your systems. Do you think our Earth stations today can be configured so that they can actually be programmed for this kind of a Iron Dome, Golden Dome equivalent, that we have a combination of radars, we have combination of flying objects, and we have a combination of all that goes into build a dome protection system? Will our Earth stations step into that kind of a service? Yeah, please. Yeah.
Wasn't sure it was addressed to me. So, today we have a worldwide network of RF sensors, completely passive, who are monitoring all satellites, whatever they are. GEO, we started by GEO about 10 years ago. And Leo and Mio, we did some trials. First trials were 3 years ago, and now it's in operations for the French DOD, but it can be used also by other countries. So we monitor, we have a refresh rate of, depending on the configuration, between 12 and 15 minutes currently. So this is the limitation, okay, for to detect any movement or anything going on into space. We don't have limitations regarding the weather. We don't have limitations about distance. So the only thing is that there are so many satellites to monitor, so many objects. I mean, as soon as the object is transmitting, we can identify it. And we say we do fingerprint of the flying objects. So we know the frequency, we know the modulation, and and these are the main information, knowing that you can have several frequencies on the same flying objects. So and it's tracked by these ways, so it cannot hide behind another object, and we will get the signature. So then there's the concern about hypersonic is today the interception. Detection is one thing, but interception is another thing. This is my outcome.
Okay, so we have one second. Let me ask this question because maybe you can help there also. We've been talking about launch on demand. All of a sudden there's a surge capability. You did not cater for spectrum. You did not have connectivity worked out. There was no ITU clearance. All of a sudden you say, I want a surge capability in the space for contingency, which is whatever you can talk about. Can we hitch a space plane? Can we launch a satellite last minute? Can we do whatever is required to be done? And will the Earth station or the ground segment be able to completely absorb them for the command and control and for downloading the data and doing all that a satellite can do, which has been pre-configured? But here it is, tomorrow morning it's going, so do something about it.
Now, the configuration of a ground network, I mean, can be a matter of a few minutes, and we can do double check, and we have long loop tests and things. So this is easy to configure, whatever is the frequency. We need to, depending on from where you are sending the satellite, I mean, you need to have the ground station close, and you have to define, and this is something that Geminus is doing. It's all the identifications of the trajectory of the launch vehicle, the separation between the launch vehicle and the satellite. I mean, all these kind of thing will define, let's say, the ground network of antennas to be available and things like that. And thanks to the tools they are developing, also we have all the information about the status of the antenna. Is the antenna available at that time, configured correctly? Is there a technical problem with that antenna, so we can switch to a backup antenna? So it's very powerful.
Anybody wants to join this discussion? Yes, Kalan.
So coming to your first question regarding that A2AD. So right now, even in fact, the Air Defense Directorate had also said that just talk to the indigenous capability to take on even swarm drones. Right now, we're not having that. But if you have to go against the hypersonics and also we are negotiating and all, and I'm sure you're aware that S500, if from Russia, if you could get, we already got S300, which did a wonderful job. And so if you need to have systems like S500, we have to go to the buy global procurement route to take on the hypersonic missile threat. Right now, indigenously nothing is available. Coming on to the and the capabilities of the system are, you can take a range of 600 kilometer range for this hypersonic light vehicles. Reaction time is less than 4 seconds. And S500 is designed to bridge the gap between traditional air defense and ballistic missile defense. Coming to launch on demand, there's already defense-based challenges, you are aware. So in the triad, it could be the land-based, it could be the naval-based, or it could be the air. Air is the most costlier option. The land and the naval platforms are being looked at. There are Indian companies who are looking at it because of the audience here can't go into specific details, but yes, this something is being done on that, sir.
Thank you. Yeah. Yeah, Shri, that young girl there.
Just one question, if you could just clarify the spectrum part of it. What is the world, army is doing about it? Because spectrum, they also must be very low on it. That's one. Secondly, is there any regulation in which you could probably do some impressment during the hot war or various phases of war on the particular spectrum so that we get free access to it? Now, what is the protocols in this?
So, sir, to answer the first part of the question, that so as I told you, this crucial band is known as mid band. Now it is roughly divided into two parts. On one side is extended C and C band, on one side is X band. So certain region 1, region 2 countries, they are already having access to X band as a military band. So it's exclusive right over there, and I'm sure it is going to be protected at least in those regions. Now here in region 3, so again, like if we look at geopolitical point of view, we need to have protection, but then the stakes and everything, they get into kind of conflict of interest. So the answer to first question is that across the regions, either the C part or the X part, one of this is definitely being protected on an alternate, like it depends on the policy or depends on the regional point of view. And second is the felt need. So as I brought out, sir, the technology can progress infinitely, but what is required is that assurance of service in adverse conditions. That is where the robustness of this mid-band comes into play, and that is why it is so precious and so price commodity, and that is why this regulatory things which are going around, sir.
Yes. I'd like to start with answering the first question of what industry would need to provide for the countermeasure and day-to-day of hypersonic. The biggest challenge, as known with hypersonic...
I don't think so people can see you. They're all trying to find out who's speaking.
So the current biggest challenge we have with hypersonic is that they maneuver at altitude which is too high for our traditional point systems to detect, yet too low for our space surveillance to tackle. So that is where we would require platforms which can sustain at the altitude hypersonic glide vehicles can maneuver and constantly track the track from their birth to death cycle. At the same time, another thing from industry that would be required is a platform to mimic this hypersonic glide vehicles so that we can train our interception systems on one hand and also the people operational of it. To answer the second question of how we would be able to use this, utilize this high maneuverable systems for the surveillance or specifically launch on demand, having high maneuverable hypersonic platforms will be able to help us during in this war situation to launch such vehicles for a short period of surveillance and reconnaissance and come back and land, not only come back and land and be launched again on requirement, and also maneuver the orbit as and when required at a faster rate to match the demand of the situation.
Okay, Samay has just come and spoken to me, and I think time is over. You have anything pressing to communicate?
Just one very small info is from Mr. Sireesh. You just brought out that you are developing your product which is likely to be in TRL level 9 or 8 or 9, whatever. As per my information, even DRDO is also developing. So are you people in touch with each other, or they are not? They are on their own?
So in India, there are only two companies which are developing this kind of system, sir. One is TIFR, Tata Institute of Fundamental Research, and DRDO. So the reason for us to start this particular company is, before to this, I was with Skyroot, and during there, we used to get lot of requests for the in-space test qualification, okay, for the near-space test qualification. And there are not enough companies in India who are supporting that. And that's when we looked out, are there any commercial companies who are offering these services? And we identified this gap. That is how we started with this one. But we are open to collaborate with DRDO as well as TIFR.
Within this time, if you have reached, within 4 months, if you're likely to reach to tier 11, it's a good progress, I must say that. Because DRDO was asking for some 2-3 years for this thing.
So, yeah, to answer
she collects money later on. So, yeah, you can quickly
Yeah. So, General Pannu has asked a question before, like, have, the validation of this technology in the near space. So, if we look into the airships or blimps, they've been from the World War I. So, it is something not new that we would be operating, especially in. But in the last 100 years, the technology, especially into the materials and other systems, have been advanced, quite drastically. So by utilizing that, we can develop a better system. That is the first thing. And India has quite a history, especially into the balloons. Some of the best launches in the world, those balloons have been produced in India and it is been supplied to them. And India also holds the highest record of the altitude, which is like 51.6 kilometers or something. That is by India. So we have those brains working along with us. That is the reason we could, reach to where we are and looking ahead. Thank you.
Thank you. So the time for paid questions is also over. So thank you. All that is left for me is to thank my panelists. They're exceptional and they are very promising. Please deal with them in B2B and talk to them. And I think they are very reassuring. Thank you very much, Colonel Dabhi, for giving the Army perspective. Jai Hind.
Thank you. Thank you very much indeed, ladies and gentlemen. A round of applause for that wonderful, insightful session we had. And we once again thank Lieutenant General PJS Pannu, who is also a senior advisor with SIA-INDIA. And ladies and gentlemen, before we wrap up this session, we have few MOUs to be exchanged, wherein Red Balloon Aerospace is getting into collaboration with few organizations. First MOU is between Red Balloon Aerospace and Endurex. I would invite Mr. Sireesh is here on the stage with us and inviting Shri from Endurex to kindly come up for the MOU exchange. The Red Balloon Aerospace and also inviting Mr. Anil Prakash, DG SIA-INDIA, to kindly come up for the MOU exchange. I would request Lieutenant General PJS Pannu to also kindly grace the MOU exchange. Being a senior advisor with SIA-INDIA, we would be honored for you to be there with us. So, ladies and gentlemen, the Red Balloon Aerospace has entered into a strategic MOU with Endurex to perform near-space qualification for the technology of reusable re-entry spacecraft designed to carry payloads to space and return them safely to Earth.
This is the MOU exchange.
So the next MOU is with Red Balloon and Rodra-Nex. I would invite Mr. Teja from Rodra-Nex to kindly come up for the MOU exchange. Red Balloon Aerospace and Rodra-Nex Space Technologies formalizes a partnership to integrate near-space platforms with new-age population systems. Through this MOU, they will jointly validate designs and integrate high-altitude and in-space technologies, including Rodra-Nex air-breathing electric propulsion on Red Balloon's near-space platforms. So round of applause for that MOU exchange. And there are two more other collaborations with Red Balloon is entering into, though because we don't have the dignitaries representing those organizations. But nevertheless, we would like to announce the collaboration brings Red Balloon Aerospace capability in aerospace systems and mission integration combined with Eon Space Labs' advanced optical imaging and space-grade payload technologies, creating a strong synergy for next-generation aerospace. Felicitating our dignitaries on the dais with a memento as a token of gratitude and appreciation. We honor Colonel N.S. Dabhi, and we would like to honor Mr. Noel Ballon. Thank you, sir, for all those valuable insights. Colonel Alok Parashar. Thank you, sir. Dr. Krishna Chandra. And Mr. Sireesh Pallikonda. Once again, we would like to put our hands together for Red Balloon Aerospace for all those very strategic MOUs that they have signed and exchanged today, and they're getting into partnerships with these 4 different organizations. Requesting Mr. Anil Prakash, sir?
Yeah, sure.
And ladies and gentlemen, kindly remain seated. We straight away move into the proceedings of the next session. Just give us a moment to get the top table ready.